Hello everyone. Welcome to qphysicsacademy. And this is Mithun Patra. I'm from NISER, SEPS. From SEPS means School of Earth and Planetary Science, and I am a planetary science research scholar. Okay, this is our lecture number 6. Okay, this is our lecture number 6, and in this lectures we are discuss. We are discuss some previous year problems of IIT JAM Physics, and those questions are basically based on previous lectures. Okay, this class, in today's class, actually we discussed from 2055 to 2018 some top questions based on the previous lectures of solid state physics. Okay, and if anyone try to contact with me, please send a email from this email ID mithunp092@gmail.com. Otherwise you can contact with me this number. Okay, yeah, that's fine. You can contact with me with these numbers. Okay, let's start our class today. This is a solid state physics class, or lecture number 6. So this is the first questions. Okay, these are the first questions. In this questions paper, you can first of all read the questions. Okay, the ratio of the here asks the ratio of the second second nearest nearby distance. Okay, second nearest nearby distance to the nearest nearby distance in FCC lattice. Okay, for FCC lattice we can find out the ratio of second nearest distance and the first nearest nearby distance. So first of all we draw a FCC lattice. As you all know, the FCC lattice looks like FCC lattice. This is a cubic unit cell. Okay, this is a cubic unit cell, and this cubic unit cell have a atoms at corners as well as each face of this lattice unit cells. Okay, sorry, each face of this unit cell. Okay, so there is 6 faces. So in the 6 faces there is 6 atoms. Okay, I put already in 4, and that is 1, and another is 1. Okay, that's fine. This is the FCC lattice. So all we know, the FCC lattice, the first nearby distance is nothing but this is first of all we mark down the atom. This is the atom number 0, and this is the atom number 2, and this is the atom number 2, and this is the atom number 1. Actually 1 stands for first nearest atoms. Okay, first 1 stands for first nearest atoms, first nearest atom, and second stands for second nearest atom. Okay, so we are already know how to calculate the first nearest distance and the second nearest distance. So this is the lattice parameter, and this is called A, and this is also a, as this is unit cube, it's the same side. So first to calculate the first nearby distance, we calculate this distance actually. Okay, so for calculate this distance, first we calculate this distance, the corner distance of this corner, and then divided by 2, and we can easily calculate the first nearby distance. So we use the Pythagoras theorem. Using Pythagoras theorem, second near distance is SD. Second near distance is equals to root under a square plus a square, that is equals to root 2 a square, and that is equals to root 2a. This is the and it must be divided by 2. It must be divided by 2 and it must be divided by 2. So that is the answer is equals to a upon root 2. So this is the second near distance. And now we calculate sorry. I'm sorry. This is not a second near distance. This is the near distance. I'm very sorry. This is the near distance. First near distance. Okay, I'm sorry. Please be careful. First near distance. Okay, this is the first near distance. Please clear. The first near distance. And next we calculate the second near distance. Second near distance is nothing but is equals to the size of the unit cell. This is equals to size of unit cell, that is equals to A. Okay, that's fine. Now we calculate the ratio of second near distance and first near distance. So ratio of second near distance, second near distance upon first near distance. Okay, so second near distance is nothing but A and first near distance is nothing but A upon root 2, so it is equals to root 2. So I think you got the answer of the given questions. It's nothing but a root 2. So option D is the correct answer. Option D is the correct answer. Okay, that's fine. I think you understand how what is the step are actually used here. So answer is option D. Okay, so please be careful about that. So first of all we calculate the first near distance, second near distance, and then we calculate the ratio between this. Okay, so please remember this pictorial form for calculating the first near distance and second near distance. What is the first near atoms and the second near atoms? It's very important. I already discussed about for cubic lattice or BCC lattice, what is the first near atom and the second near atom. Actually we use a number configurations to identify which atom is the first near atom and which atom is the second near atom. Okay, so you always use this numbering style, and then you can easily calculate the first near distance and second near distance. So okay, this is our first question, and next we go to another questions. Question number 2. This is the question number 2. Okay, and this questions is asked in 2009 question paper. In this questions they ask a monochromatic X-ray. Okay, a monochromatic X-ray of wavelength 1 angstrom are incident on a simple cubic crystals. Be careful, simple cubic crystals, it's important. And the first order Bragg's reflections, it's mean n equals to 1, and simple cubic crystals, it means there will be no additional plane. We already discussed this. Bragg's reflections from 3 1 1 plane. Okay, this is given actually Miller indices occurs, and planes occurs at an angle 30 degree from the plane. It means Bragg's angle. We are already discussed in our previous class. When we angle take from the plane, this is called Bragg's angle, and when angle is taken from normal of the plane, that is called incident angle. Okay, one is theta b and theta b. When take theta b is actually theta b is measured from the plane, and theta is measured from the normal of the crystals. So I just I gave you hints. Okay, I just give you hints. This is the structure. When we measure from this plane, this is called theta b, and we measured from normal of the plane, this is called theta. Okay, so here from the plane, it's mean theta b is equals to 30 degree. Theta b is mentioned here. The lattice parameters of the crystals in Armstrong. So actually आपको a का value calculate करना है. Okay, so here given some important questions, or we get solutions. Okay, we are doing solutions. So here given wavelength is equals to 1 Armstrong, and crystal simple cubic crystals, and here the Miller indices is equals to 311. Okay, 311, and theta b Bragg's angle, actually this is called Bragg's angle, theta b is equals to 30 degree. We are calculate actually lattice parameters A. Okay, so first of all we calculate the interplanar spacings. First of all we calculate interplanar spacing. We are already know for cubic lattice what is the expressions of interplanar spacings. Okay, interplanar spacing, that is for D311, it's equals to, for simple cubic crystals, A upon actually h square plus k square plus L square. So A is A, and A is nothing but 3 whole square plus 1 square plus 1 square. Okay, it's fine. Now that is equals to A upon 9 plus 1 plus 1, and that is equals to A upon root 11. Its unit is Armstrong. Okay, so what we get the interplanar spacings have a value A upon root 11 Armstrong. Now using Bragg's law. Using Bragg's law, okay, using Bragg's law, 2D311 sin theta b equals to, for first order only get lambda. So here 2d is equals to A upon root 11, and sin theta b equals to 30 degree, and lambda is equals to, I think, 1 Armstrong. Okay, yeah, 1 Armstrong. So this is here 1, because the unit of A is also Armstrong, so there is a, it's okay. Okay, so A equals to, we get A equals to root 11 upon 2 into sin 30 degree. Okay, sin 30 degree, okay, sin 30, I mean 30, sin 30. So it is equals to, we get root 11 upon 2 into half, sin 30 degree is half, so we get the value root 11 Armstrong. Okay, root 11. Okay, get the value of lattice parameter. So this is the way we can calculate lattice parameter. So when I mention some entrepreneurs, mention some Miller indices, I mean the informations about plane and Bragg's angle, and the wavelength of using X-ray, then we calculate in this way using Bragg's law the lattice parameters. Okay, so this is your step, and here for these questions option is actually D is right? Option D is right. Option D is right. Okay, option D is right. Okay, next we go to another questions. This is question number 3, and this is where questions is asked in 2010 IIT JAM examinations. Here questions is the value of theta at which the first order peak, that means n equals to 1 in X-ray of wavelength 1.53 Armstrong, diffractions corresponding to a plane 1 of a simple cubic. Okay, that's another. Please remember this simple cubic or FCC or BCC. Those points are very important. Okay, so here also keep also have some informations that is like a wavelength and informations about plane and informations about the what kind of crystals, the simple cubic structure with lattice constant. That means a lattice parameter, so lattice constant, it is called lattice parameters also. We are already discussed about it, lattice parameters. Okay, we had already discussed about it. It is called lattice parameters, lattice parameters. It is already we are discussing our theory sessions. Lattice parameters, and it is here actually they use the another notations alpha, but we use a, don't worry. Okay, here we use actually for lattice parameters is a, but here they in questions they use alpha, so don't worry. Okay, so in solutions we are get solutions. Here given lambda is equals to 1.53 Armstrong, HKL is equals to 111, and crystal is simple cubic, and lattice parameters alpha equals to 2.65 Armstrong. 2.65 Armstrong, and you can calculate the value of theta. Okay, here theta means we get a first order peak and n equals to 1. This is for first order peaks. We have already discussed when this is the angles. We are already discussed this point. Sin theta b is directly proportional to h square k square l square, right? It means if h k l value are given, then we get already theta b as usual by default case. If you confuse here theta is Bragg's angles or incident angle, don't worry. If there is no information about theta, you choose this is always a Bragg's angle. Okay, you always choose this is nothing but a Bragg's angles. Okay, by default you choose this is Bragg's angle. Otherwise they mention this angle is nothing measure from this angle measure from this plane of the crystals. Otherwise this angle is measured from the normal of the crystals. Okay, from the normal of the crystals. So please be careful about that. If there is okay, don't worry, we use Bragg's angle to calculate value of theta, Bragg's angle. So 2d sin theta equals to n lambda. Here the value of n is equals to 1. Okay, this is equation number 1. Now we calculate the value of d. So d equals to, for simple cubic crystals, it is nothing but alpha. Alpha means A is equals to h square plus k square plus l square. Okay, and the value of alpha is equals to 2.65 and is nothing but 1 square plus 1 square plus 1 square. So this is equals to 2.65 upon root 3. So this is the value of the interplanar spacings for D111. Now just remember this value and now use here. So now sin theta equals to lambda upon 2d. So value of the lambda is 1.53 Armstrong and this is also Armstrong, and 2 d equals to 2.65 Armstrong upon root 3. Okay, that's fine. Okay, so now this value is equals to 1.53 into root 3 upon 2 into 2.63, I think 2.65. Okay, just you can calculate this value. You just calculate using your gate calculators, I means your digital calculator in your phone or in your PC, etc. Just use it and it's calculate this value. Okay, so now so theta is equals to, we get sin inverse 1.53 into root 3 upon 2.65. Okay, 2.65, and this way I get the value of, just a minute, get the value of it's nothing but a 30 degree. Okay, it is equals to approximately 30 degree. You just calculate it in your, use your gate calculator, I mean calculator software in your system, I mean PC, mobile phone, etc, etc, and then you put it. So this is the value of this angle. So this question is very easy. If your concept is clear, if your theory is clear, you can calculate easily any kind of parameters in crystallography. Okay, so you can calculate the value of theta. So we have the, for these questions I have a options is B. Option is B. So answer is B. Okay, answer is B. Next come to the another questions. Next come to question number 4. Okay, question number 4, and this question is asked in your 2011 IIT JAM examinations. And 2011 IIT JAM examinations. And X-ray diffractions, I mean XRD, an X-ray diffractions in XRD experiment is carried out on a crystalline solid having FCC structure. Okay, this have a FCC structure at room temperature, and the solid undergoes a phase transformations on cooling to minus 20 degrees centigrade, and so orthorhombic structures. Okay, with small small decrease in its unit cell and length of length as a compared to FCC unit cell length. As a result, the 311 line of the, plane of the XRD patterns corresponding to the FCC system will be split into a doublet, will be split into triplet, will be remain unchanged, will split into two separate doublet. It's a very good question. You just read it. Questions. An X-ray diffractions experiment is carried out on a crystalline solid having FCC structure at room temperature. The solid undergo phase transitions on cooling to minus 20 degrees centigrade. Actually, they use some they do some experiment. What kind of experiment? They decrease the temperatures. Okay, decrease the temperatures, and then show the orthorhombic structures and orthorhombic structures have a unit cell has small decrease in unit cell length compared to the FCC unit cells. Okay, FCC unit cell. So as a result, for 311 plane line of the XRD patterns corresponding to the FCC system, जो FCC system था उसका 311 plane will split into doublet, triplet or no change and will split into two separate doublet. This is the questions actually. So for this type of questions, what type of steps we are actually use, that is very important. Okay, that is very important. So we all are know for FCC, for FCC interplanar spacing. Okay, interplanar spacing is equals to you just look the HKL value. This is nothing but 311, right? 311. So it is as it follow the rules of FCC structures. What are the rules for FCC structures? We are already know HKL have a odd value or even value, or HKL value are odd or HKL value are even. Here all HKL value are 311. It means odd. All value are odds, right? So if all value are odd, then when we calculate interplanar spacings, and not multiply with the expressions half. It is just a formal, it's just a as usual mathematical form of interplanar spacings. All value are odd. Okay, if this is a mixing, if HKL value are mixing, I mean the value is odd or even, they are mixing, then we multiply it with the D value, which is half. But here HKL value is all odd, so this is follow the rules. So if you follow the rules, then interplanar spacings D is nothing but it's just a, as usual, cubic lattice. Formula is just like a cubic lattice. Okay, that's fine. सबसे ज़्यादा इंपॉर्टेंट है ए चेक करना, जो एच के वैल्यू है सारे वैल्यू ऑड है क्या इवन है, क्योंकि यहाँ पे एफसीसी स्ट्रक्चर मेंशंस किया है, सो दैट इज़ वेरी इंपॉर्टेंट. अगेन for orthorhombic structure, another structure is orthorhombic structures, and for orthorhombic structures we already give you what is the expressions of interplanar spacings. Orthorhombic structures क्या होता है? Orthorhombic structures means ऑर्थोरोम्बिक स्ट्रक्चर, इसमें क्या होता है? You already know A not equals to B and not equals to C. All value are not equal. So when all value are not equal, then interplanar spacing D is equals to 1 upon root under H by A whole square, K by B whole square, L by C whole square. Okay, so now we calculate the interplanar spacing value. Here these two are the interplanar spacings mathematical form for FCC crystals and orthorhombic crystals. Now we calculate the calculate the Bragg's angle. Now we calculate Bragg's angle for 311 plane. I mean these 311 planes, how many peaks are actually available? They ask actually those questions. Actually what they ask in the questions, please clear. They they mentions here two types of crystals. One is FCC, another is orthorhombic structures. And they give you one planes 311 and 311 for 311 planes. For 311 planes, we get one peak or more than one peak for FCC, and then we also check for 311 plane for orthorhombic structures we get one peak or another peak. One peak, how can I decide here one peak or three peaks or two peaks? If we calculate the value of theta v, then we easily understand, we can in very simple way understand the how many peaks are available for this crystals corresponding to the plane. Okay, so peak means how many peaks means you can calculate, we are calculate the value of theta, Bragg's angle. Okay, so please remember this point. Already we discussed about here about this point. When you know the plane, we can calculate how many peaks are available. I mean, what is the positions of peak? Calculate the positions of peak, right? Theta v. This is already discussed in previous lectures. Please go through all the lectures in sequential manner. Then you can come here and try to understand how can you solve this every problem. Okay, okay, just try to understand. Yeah. Okay. Let's say we write here two expressions of interplanar spacings. Okay, for 311, number of XRD peaks for 311 plane, number of XRD peaks in FCC crystals. Okay, in FCC, this is our heading. We'll calculate it. Okay. Okay, so sin theta is equals to lambda upon 2d, and for FCC lattice lambda upon 2a, and that is equals to h square plus k square plus l square, and that is equals to lambda upon 2a, and it's equals to 311. So 9 plus 1 plus 1, so that is equals to lambda upon 2a into root 11. Thus only one peak appears. Yeah, lambda here fixed, but a is also fixed, right? So for this plane, for FCC lattice, we get only one peak at that positions, Okay. Thus only one peak appears. One peak appears in FCC. In FCC. Okay, this is fine. Now we can calculate for orthorhombic crystals. Yeah, for we calculate orthorhombic crystals for 311 plane. For 311 plane, number of XRD peaks in orthorhombics. Okay, this is our next task. I try to solve it. Okay, so sin theta equals to lambda upon 2d, and this is equals to lambda upon 2 into 1 upon lambda upon 2, that is equals to h by a whole square k by b whole square L by c whole square. Okay, this is your expressions, right? Okay. So now here theta is equals to, we get sine inverse and lambda upon 2 h by a whole square k by b whole square and L by c whole square. Okay, this is the formal, very formal, very easy. Next, here a, b, c all value are different, right? If we interchange the value of a, b and c, just change this value of a and b, c, then Miller indices will also change, right? Okay, so here as a, b, c are different, then Miller indices have 3 combinations. Yeah, I can check a value, I also change v value, I also change 3 value, c value. It's our hand. Okay, it's the experiment part. Just try to understand what can I what can I what can I do, I can what actually I want to do, right? What actually I want to do. Okay, so if HKL is equals to 311, first this is the value of 311 with respect to 1 a, b, c, something is value, something have a value. So since theta 1 equals to, we get theta 1 value, right? Theta 1 angle, so this is equals to sine inverse lambda by 2 1 by a 9 by a square plus 1 by b square plus 1 by c square. This is the positions of one peak. Okay, but if if HKL equals to have a value 131, if we change the value of ABC, we get another plane, right? If we change ABC, then we get another plane. So then we get another angle, another peak at an angle at a position theta 2, that is equals to sine inverse lambda by 2 1 by a square plus 9 by b square plus 1 by c square. And similarly, if HKL equals to 1 1 3, then we get another angle theta 3 is equals to sine inverse lambda by 2 into 1 upon a square 1 upon b square plus 9 upon c square. Okay, so Here we get actually 3 peak, right? 3 peak. So for FCC lattice, for these planes, for this plane 311 planes, we get only 1 peak. But for orthorhombic crystals for these planes 311 planes, we get 3 peaks. Okay, so here peak actually split into triplet when FCC crystals is transformed to orthorhombic crystals. For same planes we get more number of peak for a corresponding for a one plane. This is a very important point. Please remember this. How can I calculate it, right? Okay. So please take a note. If FCC structure can transform to orthorhombic crystals, then for one plane we get we get 3 peaks, we get 3 peaks, that is XRD patterns, that is XRD patterns split into a triplet. Okay, split into triplet. Okay, I think this handwriting is very bad, right? I tried to write in very beautiful way. Just a minute here. Yeah, I just change my color. That it means XRD pattern split into a triplet. Be careful, okay? Triplet. So for these questions, we get an option B. Options B. Okay. I think you understand. Okay, next go to another questions. Yeah, this is your questions. Question number 5. I think this is very easy. For an X-ray beam of wavelength 1.54 angstrom, it is refracted from 110 plane in a solid with a cubic lattice. Okay, that's fine. It's very easy. Opaque cubic lattice constant 3.08 angstrom. Lattice constant means A. The first order diffraction patterns occur at angle पूछा है आपको. Actually, just calculate the diffraction pattern का peak कहाँ पे मिलेगा. What is the value of theta? ठीक है. So this is your homework. Okay. This is your homework questions. Your homework questions. Please solve it and send it our WhatsApp group. Okay. This is a very easy. Just very easy problems. I am confident you all of you can solve it, right? So that's why I give you a homework. Okay, that's fine. Next, to go to another questions. I think just two questions are same, no? Okay, that's sorry. I just put it here, two same questions. Just avoid it. Okay, next go to the another questions. Question number 7. That is asked in IIT JAM 2013 examinations. Actually, what uh, information is mentioned here? What information is given to you? The fractions of a volume. The fractions of a volume. Fractions of a volume occupied in an unit cell of the body center cubic lattice. The fractions of volume occupied in the unit cell of a body center cubic lattice. What is the meaning of this line? It means how many atoms are occupied in a unit cell. So that's why we can calculate. That's why we are calculate to solve these problems packing fractions. Why calculate packing fractions? Packing fractions means how much fractions of volumes are occupied by atoms. This is the meaning of packing fractions. So what is the meaning of packing fractions? Packing fractions means how much fractions of volumes occupied by atoms in a unit cell, right? So here asks you the fractions of volume occupied in the unit cell for body center. So here we can just calculate the formal way, body center cubic lattice, right? So for body center cubic lattice, body center cubic lattice, the fraction of volume occupied by the atom in unit cell. Fraction of volume, oh sorry, unoccupied. I just mistake here. Unoccupied. I just unoccupied. Okay, we have calculate in our lecture fraction of volume occupied in the unit cell, right? Fraction of volume occupied in the unit cells. But here asks you fraction of volume unoccupied. Okay, when you calculate a fraction of volume occupied in the unit cell, it's called packing fractions, and then we subtract this value from the volume of this unit cell. We can calculate the how much fractions of volume unoccupied in the unit cells. Okay, so please be careful. They ask unoccupied or occupied. It's a very contradictions. That is basically, it's a very big dilemma, right? This is a very big dilemma. Students are do mistake. So I suggest you be careful, and when you solve this type of problems, this easy questions have a lots of options for your mistake. So be careful when you solve easy questions, right? In your examinations, easy questions actually reduce your marks, right? Reduce your marks. Otherwise, if you be careful, this easy questions increase your marks. Otherwise reduce your marks. There will be lots there's options, because everyone do this type of questions. If you do wrong, if you do wrong, then your marks will be reduced, but other students marks will be increased. So be careful. Okay, the fraction of volume unoccupied means, what is the meaning of fraction of volume occupied? Fraction of volume unoccupied is equals to volume of unit cell minus fraction of volume occupied, that is called atomic packing fractions. Okay, atomic packing fractions. So for BCC crystals, we are already know how to calculate atomic packing fractions. We'll just revise here how to calculate atomic packing fractions for BCC crystals. We just calculate here. So for calculate the atomic packing fractions, we calculate two parameters: a number of atoms per unit cells, and we next calculate the radius of number of atoms per unit cells and volume of this unit cells. Okay, so first calculate the effective number of atoms, the effective number of atoms in BCC structure. In BCC structure, in effective, that is equals to, we have a formula, 1/8 equals into NC plus 1/2 into phase plus Ni, number of atom inside the crystals. So for BCC crystals, there are only one atom at the middle body center positions, and there are no atoms in the phase, 1/8 NC equals to 8 plus 0 plus 1, so we get 1 plus 1, so 2. We already calculated this value, the effective number of atoms in BCC structure. Next point, we calculate what is the radius of atoms in BCC structures, right? BCC structures, the radius of atom, the radius of atom, the radius of atoms, this is our next task. So you always calculate, for calculating the radius of atoms, we use an approach that is nothing but we always approach, that means okay, just look at the pictures. There are different pictures. We use another picture, we draw it. Okay, we draw it here. Okay, this is your first positions, and this is your second. Okay, this is the actually this is the 0th number of atom, and this is the first number of atom, that is first Navier distance. Okay, and this distance is nothing but the corner distance, actually half of the corner distance. Okay, first Navier distance means half of the corner distance. Okay, so here I have three atoms, and each atom have a radius r. You all already know r equals to radius of atom. Okay, as there are three atoms, so it's equals to r. So this distance AB, this is called AB. So AB is nothing but R plus 2R plus R. For this atom we get only R value, for this atom we get R plus R, that's mean 2R, and for this atom we took only R value, so that is equals to 4R. And this 4R equals to, actually 4R equals to, we get this value equals to A, and this value is equals to root 2A, and this value is equals to A. So here AB equals to, again from this pictures, AB equals to, we know root 2A square plus A square. We are already calculated, right? So 2A square plus A square equals to root 3A. Okay, so 4R equals to, we get root 3A and R equals to root 3A upon 4. This is the radius of the atoms. Okay, that's fine. Okay, yeah, now we calculate volume occupied by the atoms in the unit cell. Volume occupied by the atom in the unit cell is equals to, there are 2 effective number of atom, and each atom have a volume 4/3 pi r cube. So that is equals to 8 upon 3 pi r equals to root 3A upon 4 whole cube, and that is equals to, actually, pi root 3 upon 8 to A cube. So this is the volume occupied by the atom in the unit cells. Okay, so thus amount of volume unoccupied in the unit cell H equals to total volume of unit cell minus volume occupied by the atom in the unit cell. Okay, volume occupied by the atom in the unit cell. Okay, that's enough, and this is equals to A cube minus pi root 3 upon 8 A cube, and this is equals to 8 minus pi root 3 by 8 into A cube. Okay, this is your answer. I think this is your answer. Yeah, that's fine. I think we please remember this is not atomic packing fractions. Okay, just like atomic packing fractions, just like atomic packing fractions, we are not considered here for these questions, to solve these questions actually. Okay, don't worry. Yeah, that's okay. You can just correct this. Yeah, that's fine, but okay. Volume occupied by the atom in the unit cell. Okay, that's fine. Yeah, just can do it. Just you can do it in the formal way. This is the questions, and actually क्वेश्चन में फ्रैक्शन पूछा था, तो फ्रैक्शंस वही है ना, आपको ए क्यूब से जस्ट डिवाइड करना होगा फ्रैक्शंस कैलकुलेट करने के लिए, जस्ट वही है, कोई बात नहीं, अब सेम ही है, जस्ट इससे कोई डोंट वरी, है ना। देखिए ऑप्शन में कोई ए क्यूब तो नहीं है, मैंने जस्ट ए क्यूब जैसा कैलकुलेट किया, इसलिए मैंने इसको चेंज किया, इससे कोई रॉकेट साइंस नहीं किया मैंने इसको, जस्ट फ्रैक्शंस कैलकुलेट करने के लिए तो टोटल वॉल्यूम से तो डिवाइड करना ही पड़ेगा ना, तो आपका आंसर ऑलरेडी मिल जाएगा, तो मैंने जस्ट वॉल्यूम कैलकुलेट किया, इसलिए वहाँ पे एक्सप्रेशंस को थोड़ा बहुत चेंज किया, ऐसा और कुछ नहीं, जस्ट रिमेंबर, ठीक है। तो यहाँ पे भी शायद फ्रैक्शन नहीं होगा ना, हाँ, यहाँ पे भी शायद फ्रैक्शन नहीं होगा, वॉल्यूम अनऑक्युपाइड, दिस इज योर, फ्रैक्शंस भी आप लिख सकते हो, कर सकते हो, जस्ट लास्ट में आपको क्या करना पड़ेगा पता है, ए क्यूब से डिवाइड करना पड़ेगा, यही बात है और कुछ नहीं, जस्ट इससे कोई इतना हम लोग बड़ी बात नहीं है इसमें, जस्ट अब जैसा आप करोगे, जैसे है, मैंने पहले फ्रैक्शन लिखा था, मैंने जस्ट आई फॉरगॉट अबाउट दैट, जस्ट कैलकुलेट अबाउट द अमाउंट ऑफ वॉल्यूम, बस यही है। ओके, डोंट वरी, नेक्स्ट गो टू अनदर क्वेश्चंस। Okay, now for these questions option A is correct, right? For these questions options A is correct, you already know. Yeah, these are next questions. Question number 8, the next questions. Question number 8, question number 8 is very important. A diamond lattice can be considered as a combination of two FCC lattices. Yeah, of course, diamond lattice is a combination of two FCC lattices. Okay, FCC lattice, and displaced along the body diagonal by 1/4 of its length. Okay, ओके, आपके पास देखिए डायमंड स्ट्रक्चर भी है, आप इसको जस्ट इमेजिन करने की कोशिश कीजिए, देयर इज ए टू एफसीसी लैटिस, जस्ट यू फोकस द इमेज पार्ट एंड ट्राई टू अंडरस्टैंड how two FCC lattice are actually combine each others and form a diamond structures. Please be concentrate here and try to understand. Just imagine this is your homework part and try to, ये खुद से करने से अच्छा होगा, आप खुद से इसको समझने का कोई कोशिश करो। आपके पास मैं 2 पिक्चर्स ऑलरेडी मैं यहाँ पे आपके पास मेंशन है, तो क्या आपसे थोड़ा बहुत जस्ट खुद से पूरा गूगल करिए, ऐसा कुछ उसका 3D एनिमेशंस वगैरह भी है, अगर आप यू कैन गो गूगल एंड just try 3D dimensional structure, diamond structures, then you in your windows you can you see various kind of 3D animations pictures of diamond structures, so it's very easy to understand, so just try to understand yourself. Now I am just focused to how to solve this kind of problems. Okay, your task is try to understand the dimensional structures and how a dimensional lattice can be formed by combinations of two FCC lattice. This is your part. My part is only focus how to solve diamond lattice crystals. Okay, this is your part, and my part, my job is to solve these questions only. Okay, diamond lattice can be considered as a combination of two FCC displaced along body diagonal by 1/4 of its length. There are 8 atoms per unit cell. Okay, please remember this point. Please remember this point. For diamond crystals, we have a number of atoms per unit cell is equals to 8. Please, this is very important informations. Okay, very important informations. And the packing fraction of the diamond structures. Okay, packing fractions of diamond structures. We just focus about that. Diamond structures of packing fractions. Yeah. Okay. Try to understand. Please try to understand. Okay. Not skip it. Just try to understand. Okay. अगर समझने का कोशिश नहीं करोगे कैसे चलेगा, है ना जी? Just try. Okay. As you know, the definitions of packing fractions. What are the definitions of packing fractions? N effective into volume of one atom, right? This is nothing but the volume of atom occupied in a unit cell. This is nothing but, and this is equals to total volume of unit cells. Volume unit cells B. So if you write, it's equals to N TF into 4/3 pi r cube into a cube. So for diamond lattice, there are 8 number of effective number of atoms is equals to 8. So we know the formula N effective, already discussed here. 1/8 into NC corner atom, 1/2 into NF and NI. Just use this formula and calculate N effective is equals to 8 or not. Just calculate. Okay, is your task. आपका काम खुद से करना सीखिए. मेरा काम ये नहीं जस्ट आपको तोते के जैसा सॉल्व कराना है, नहीं, जस्ट थोड़ा बहुत टास्क खुद भी करोगे तो खुद का इम्प्रूव भी होने वाला है. ठीक है, तो खुद का इम्प्रूव, मेरा काम सिर्फ पढ़ाना नहीं है, आप लोगों का इम्प्रूव भी कराना है. सो दैट्स व्हाई आई ट्राई टू गिव यू सम होमवर्क. ओके, just imagine the structures. When you imagine yourself, then you feel something, right, about crystallography, like that. Okay, that's fine. Next our task here is N effective is equals to R 8. So 4/3 pi r cube equals to upon a cube. Yeah. Next, we calculate the value of R. Yeah, right? You calculate the value of R. How can I calculate it? That is very important. That is the learning part, right? So for diamond structures, for diamond structure, radius of atom calculations. ठीक है, ओके, ठीक है. आप सोचिए, एक बार कुछ सोचना पड़ेगा. यहाँ पे सोचने वाला बात है, कुछ सोचने का बात है. मैंने बोला डायमंड इज नथिंग बट ए कॉम्बिनेशन ऑफ 2 FCC लैटिक्स, राइट? है ना, कॉम्बिनेशन ऑफ टू एफसीसी लैटिस, ठीक है। तो एफसीसी लैटिस में, एफसीसी लैटिस के लिए, एफसीसी लैटिस के लिए एटम का रेडियस क्या होता है, पहले आपको ये समझना पड़ेगा, ठीक है। एफसीसी के लिए, फॉर एफसीसी क्रिस्टल्स, हाउ कैन आई कैलकुलेट द रेडियस ऑफ वन एटम? जस्ट फोकस ऑन दिस फेस, you just focus on this phase, just focus, okay, you can just focus on this phase. This is the first near atom, okay, this is the first near atom actually, okay. I just trying to calculate this distance, just trying to calculate this distance. This is the first near distance, then you will easily calculate this value or diagonal of this face, right, है ना। इसको हम लोग A नाम देते हैं और इसको हम लोग B नाम देते हैं। सो ये भी इज नथिंग बट 4r here also, 4r, 4r, how can you say 4r? Similar, r plus 2r plus r, so that is equals to 4r. Again, this is just a फेस डायगोनल, एक फेस का डायगोनल आपको कैलकुलेट करना होगा। वो क्या होता है? फेस का डायगोनल, जस्ट यू कैन इमेजिन्स, okay, just you imagine how can I calculate the value of AB, right? So just you calculate, imagine, प्लीज़ एक बात आपको याद रखना है, ठीक है। इस डायमंड स्ट्रक्चर के लिए अगर आपको एटॉम का रेडियस कैलकुलेट करना है, यू फॉलो द रूल्स ऑफ बॉडी सेंटर क्यूबिक लैटिस। इसको नोट करके रख के रखिए, इसको जस्ट नोट डाउन करना है, ठीक है। हम लोग नेक्स्ट क्लास में ना इस डायमंड स्ट्रक्चर को लेके एकदम डिटेल स्टडी करेंगे, वी लर्न अबाउट एनीथिंग्स, एक एक पॉइंट को हम लोग डील करेंगे, ठीक है। आई फील you also feel a difficulty to understand the principle, understand the process, understand the how to calculate the parameters for diamond structures. I can feel for that. That's why I have a plan. I discuss about anything of diamond structures, okay. Just here to solve this problem, just to remember, for diamond crystals, calculate the value of radius of one atoms, we follow the rules of body center cubic lattice, okay. We follow the body center cubic lattice. So body center cubic lattice, इसमें क्या होता है, 4r इक्वल्स टू होता था √3, एक होता था ना, √3 होता था, √3a होता था, राइट। अभी आपको क्या करना है, देखिए वो तो बॉडी सेंटर क्यूबिक का था, बट यहाँ पे 2 एफसीसी लैटिस एक्चुअली कंबाइन ईच अदर, सो दैट्स व्हाई वी जस्ट डिवाइडेड इट्स इक्वल्स टू बाय 2, okay, we just divided by 2, so hence we get r equals to √3a by 8. डोंट वरी, हम लोग बात करेंगे कैसे आ रहा है ना इसका, अभी तो इसके पीछे हम लोग पड़ जाएंगे, तो प्रॉब्लम और अदर्स प्रॉब्लम भी थोड़ा सा स्किप हो जाए। मेरा प्लान थोड़ा सा, मुझे जस्ट फॉरगेट अबाउट द डायमंड स्ट्रक्चर के बारे में मुझे पढ़ाना भूल गया था एक्चुअली, ओके, नो प्रॉब्लम। आई गिव यू ए वीडियो ऑल अबाउट diamond structures, all about initial structures, all about zinc ZNS structures. Okay, don't worry, I give you diamond structure, diamond. Second point, I give you NaCl, I give you also ZNS. Okay, so don't bother about that, ऐसा मत सोचिए, थोड़ा बहुत याद रखना होगा, नहीं बात करेंगे इसके ऊपर, ठीक है, बात कर लेंगे नेक्स्ट लेक्चर्स में, बात कर लेंगे. ओके, सो डोंट वरी यार, डोंट वरी, वी चिल. ओके, सो R equals to root 3a upon 8. So this is the radius of diamond crystals. Yeah, right. This is the radius of diamond crystal. Diamond crystals के लिए radius आपको मिल गया, है ना? So now packing fractions PF is equals to 8 into 4 by 3 pi root 3 by 8 whole cube a cube upon a cube. इसका वॉल्यूम तो सारे ए क्यूब ही होगा ना, इससे कोई फ़र्क ही नहीं पड़ता. ओके, ए क्यूब इज कैंसिल each others. So when you just calculate, you get the value root 3 pi upon 16, and this value equals to 0.34. Please be remember that is equals to 34%. It's very important. This is a very loose packed structures. Diamond structure is very loose packed structures. Okay, हम लोग बात करेंगे सर. We talk about that. About those, right? About those diamond structure, NaCl structure, ZNS structures, everything. We talk about that. It's very important for your learning part. It's very important. Okay. Please be careful about that. So okay, so diamonds के लिए we are just calculate the value of packing fractions. I have a problems. Actually, we have a problem, right? We have a problems. That is this. How this value we can calculate? How can I value? How can I calculate this value? Okay, don't worry. Next class will clear about that. All about that. Okay. So next we go to another questions. Yeah, question number 9 in 2015. The number of second near distance of Na plus ion and NaCl crystals. Okay, again I told you, don't worry. How can I calculate? What we discussed all about NaCl and diamond and everything. Okay, so let's do it. NaCl structures. Number of second near ions. The number of second nearest near ions. Okay, number of second nearest near ion of Na plus ions in NaCl crystals. Na plus crystals के फर्स्ट सेकेंड नियरेस्ट में कितने नंबर ऑफ एटॉम्स है पूछा है. मैंने बोला था ना, बहुत क्वेश्चन पूछता है इससे आपको. फर्स्ट नियर एटॉम कौन सा है, सेकेंड नियर एटॉम कौन सा है, ये बहुत अच्छे से जानना जरूरी है. ठीक है, तो इसके बारे में हम लोग वी आर डिस्कस, राइट. या फर्स्ट ऑफ ऑल हियर वी गिव यू पिक्चर्स. One is one is a circle is a Cl minus, and is a bold structure is a Na plus ion. All are the Na plus ion. Okay, yeah, but in our questions they asked you number of second nearest neighbor of Na plus ion in NaCl crystals, right? Okay. Okay. NaCl structures even FCC structures. Just 1 second. I can give you hints. How can you calculate this those values actually? I can give you a hints, right? How can you calculate those values? Yeah. Okay. The number of second nearest neighbor number of second nearest neighbor is equals to, I just give you informations. Next we discuss about that already, because we just use a trick. Okay, we just use a trick here, but details explanation is very vast, that's why I skip this. Okay, I just give you a information. You just write down your copy, and after discuss about all thing of NaCl or diamond or ZnS, then you familiar with how can I calculate the number of nearest neighbor, how can I calculate the radius of one atoms, and etc etc. So don't worry, you just write down in your copy the number of second nearest neighbors ions for Na plus or is equals to 12. Okay, yeah. Next we go to the another questions. Yeah, this is a question, question number 10. They asked in 2016. 2016. What's the questions? Question is X-ray diffractions of cubic crystals. That is cubic crystals. It's very easy. Given as intensity maximum of Bragg's angle 20 degree, Bragg's angle, that's mean theta b. Okay, theta b corresponding to the plane 110 planes. The lattice parameter of the crystals is ये क्या वैल्यू आपको पूछा है. It's very easy. This is your homework. Okay, this is your also homework. This is your homework. Next we go another questions. I think this is I think you should be do it right. A plane in a cubic lattice makes an intercept with 3 crystallographic axes respectively. The Miller indices of these planes are, yeah, etc. Hey, this is your homework also. You can do it. Homework. All are homework. कुछ क्वेश्चंस यहाँ पे होमवर्क आपको मिला. Just solve all the homework questions. Okay. Okay, don't worry. 2017 questions we are discuss in our next lectures. There will be also NaCl and KCl. It's like a structure. So इसके लिए पहले आपको first of all you try to know about what is the NaCl structures. So okay, we discuss about, then you easily solve it, right? So don't worry. I think it is very easy questions. Okay, just give you hints. How can you solve it? KCl has an NaCl type structures, which is FCC, structures with 2 atoms in basis 0 and other is at this point. Okay, assume that the atomic form factor of K plus and Cl minus are identical in X-ray diffractions pattern on KCl. Which of the following HKL peaks will be observed? Actually, we know the rules of FCC structures. Use these rules. FCC structures, rules of FCC. HKL, all are even Alls are even because NaCl is an FCC structure and KCl also be FCC structures. That's why. And or all are odd. Just check. First option A, one is 100, that's mixing of all and even. Second one is also 110, mixing of 110, and another is K11, this is the only word, and 200 is equals to 200, also all are all are all are even, and here all are odd. But there will one contradictions in KCl. In KCl, reflections from one layer containing Na plus ion is exactly out of the phase, and with the reflections from Cl minus close packed layer. So the net effect is that two reflections cancels and one is absent. So this means that the first reflections from 200. Actually for FCC, those option C and option D both are we consider, right? But for KCl, the reflections from one layer containing K plus ion is exactly out of phase with the reflections from Cl minus ion reflections. So as the out of phase, these two reflections are actually cancel each others from one plane. This is a theory. Okay, this is a theory. So please remember this theory. That's why for KCl, this is the point. This is the point for KCl. Reflections from one plane is absent, only 200. Please remember this. In your examination, these questions ask you some in a MSQ manners. Okay, so just note down in the point and be careful about that. So option D is the correct answer from this part. Okay. Yeah, this is a very good question. Very easy. Question number 13, 2018. Which of the combinations of the following crystals structures, their coordinations number each? Okay, body center is cubic, etc, etc. It's your homework. Just do it. I give you hints, something. This is your homework. Just do it. Okay, and this is the question number 14. The lattice constant of the unit cell of NaCl crystals is 0.53. that's A value. X-ray of the wavelength is nanometer, and the diffracted by this crystal, and the angle at which first order maxima occurs is we know the NaCl structure. NaCl is nothing but a FCC structure. So for FCC structures, we can calculate those value. Calculate the value of angle at which the first order maxima is occurs actually. Okay, let's solve it. Right, let's solve it. क्या क्या mention है given है? Yeah, that's the questions. Here the lattice NaCl unit cell NaCl crystals lattice constant is mentioned. A is equals to 0.563 nanometers. Okay, unit are same. Wavelength lambda is equals to 0.141 nanometer, and diffracted by these crystals, the angle at which the first order maxima, that is n equals to 1, first order maxima for n equals to 1, and we calculate theta equals to what? Right. So the angle at which the first order maxima occurs. This is a very good questions. Okay, we use the Bragg's law. 2d sin theta equals to n lambda. So sin theta equals to lambda upon 2d, because n is over 1. N is 1, and what is the value of d for maxima? Actually maxima, as we are all know, for FCC, right? FCC structure, NaCl is FCC structures. FCC structures max HK planes. You consider, just imagine 1 0 0 0 1 0 0 0 1 and 1 1 1. Which plane we are consider actually for first order diffractions? This plane is no, because this is a mixing. This plane also no, this plane also no, but we only consider 1 1 for FCC, right? For FCC, but KCL this plane is absent, and NACL this plane is present. From this plane we get the maximum on the first order maxima occurs actually. Okay, so please remember this point. So for NACL crystal first order maxima, for first order maxima interplanar spacing, then we use this HKL value. Okay, so lambda equals to 2a upon root 3, so that is equals to root 3 lambda upon 2a. Okay, root 3 lambda upon 2a. Okay, so theta equals to sin inverse root 3 0.141 upon 2. A is nothing but 0.563 and you get the value sin inverse 0.217 and it is equals to 12.53 degree. Okay, so this is your answer. So just be careful at that point. For FCC crystals, first order maxima occurs from this plane. Just remember, because from 110 plane is not considered. This is actually not valid plane for FCC. 010 this is also not valid for valid plane. 001 this is also not valid, but only valid is 111. Then 121 it's not valid. 211 not valid. 112 is not valid. Then 2222 it's valid, right? 222 it's valid. This is second order peak. Actually, we get second order peaks, right? But 311 it's also valid. 311 is valid. 312 is not valid. 313 is valid. This is the process for FCC lattice. Okay, so please be careful about that. For FCC lattice, we get maximum peak. We get maximum peak of first order from 1 plane FCC lattice, right? So please remember this, all the point. When you make a notes in your copy, just try to write down. Just try to write down all the points, all the concept I can give you, I discuss with you. This is important. Okay, और क्वेश्चन है क्या? एक सेकंड देखते हैं. नहीं, और क्वेश्चन नहीं है. तो आप लोग यहाँ पे एक नोट करके अब लिख लीजिए. जो 1 प्लेन है ना, 111, this is actually used for first order diffraction peaks, right? First order XRD peak for FCC, only for FCC, because rest of the planes are not a valid plane for FCC. Okay, that's fine. Our class is now over, and in next lectures I discuss with you, I give you about I give you informations, and I give you concept about NACL, about ZNS, about KC, about NaCl, about ZNS, about diamond, about KCl, everything we discuss about that video. Okay, this all are important in your IIT JAM examinations. I think these crystal structures are not important in your semester examinations purpose, but my channel aim is actually give you some valuable content for all examinations. If you crack this type of exam, also you perform better, perform well in your semester exam also, as well as in some competitive exam. Okay, so that's okay, that's fine. You can learn with me, just share with your friend these videos, and just like my videos also. If anyone is new in my channel, subscribe and like and share, and just the formalities, I know. That is the formality. It's just a formalities. Formalities means, you know, what is the meaning of formalities? Formalities mean it's not necessary, but this is important for institute. Formalities is a formalities. You just know when you go in any kind of institute, that is just a formality. You can fill up these forms and submit here. Just a formalities, just like it. When you new here, I mean new in my channel, just a formality. Just put the subscribe button, and then you be ready for your next task, I mean next journey. Just like when you go in institute and do some formalities, and then start your journey, just like it, just like that. Okay, don't worry, this is the funny part. Okay, thank you, and we'll meet again. We'll meet you soon in next class, then I discuss about everything. Okay, don't worry. And again I told you, if anyone feel any kind of difficulty to understand the concept, understand the problems, how can you use this type of principle, what I can use this type of concept, please put in my WhatsApp number, this form. I can give you some suggestions, I can give you some reference. Okay, so don't hesitate, don't be shy, just communicate with me, and clear all the concept. Okay, thank you, and keep learning, and have a good day. Yeah, let's see you soon next. Okay, let's